All right. Good. What is it? Say good. Good afternoon. We're going to continue our discussion of the current module. Ms. Goma, I see you're online. Do you want to maybe give us a sign as to whether you can hear me? I don't want to activate my speak on my other mobile device. I'm about to log in because we'll have echoes all over, right? Are you able to maybe give us an indication as to whether you can hear me?
Yes, I can hear you.
Okay, wonderful. So we're going to an appreciation of some of the key elements associated with a class diagram, right? In essence, we discovered, and it's quite unfortunate that you were not introduced to OOP concepts, object-oriented concepts, object-oriented analysis and design, OAD. But what we saw was that we can take advantage of this approach to program where you model using something else. So we discovered that your so-called diagrams are actually or actually comprise certain key elements, so the class or the classes with associated relationships. Now, the interesting thing, so classes and relationships. So you'd explicitly indicate after identifying the classes associated with this system, you would then identify how exactly these different classes are linked together. So in other words, what sort of relationships ideally would exist amongst these different classes. Okay, so a discussion of that, and then I think something else that perhaps I would say was interesting is this notion that and I don't know if this came out here, but I did mention so-called the significance of including relationship names and also the multiplicities, right? So that ultimately you have something similar to this, where The association is indicated using some kind of solid line, if you will, okay, with the name of the relationship. And then additionally, apologies for that. My connection, my liquid connection is a bit off here. But I was making mention of the fact that we discovered that your so-called class is associated with certain key elements here. So you obviously have the class name, and you have your attributes or characteristics, and you have your methods or operations, right? And typically, when we're using the unified modeling language, would represent our class, right? It's not comprehensive, but it gives us an idea of what sort of information we are meant to include, right? And then we also introduced this notion of specific types of relationships that exist amongst these different classes. Um, we discussed your so-called generalization, um, uh, uh, and we realized that uh, we realized that um, we realized that when it comes to generalization, what we are modeling here, we are modeling things like a parent-child relationship, right? Um, we are also modeling things like a superclass and a subclass kind of relationship. Things like uh, uh, this is like parent-child, superclass, subclass, parent-child, and all those things, right? Anyways, so we did that, and in fact, we gave an example of exactly how we represent this using unified modeling language. Uh-huh. Um, anyways, and it turns out that there are um, there are other types of relationships that exist. Okay, so for instance, you have so-called aggregation. Now, the idea behind um, aggregation here is that you're trying to showcase how classes are classes that are collections. You're trying to demonstrate how classes which are collections are composed of other classes. Okay, um, it's a so we discussed composition just now. It turns out that aggregation um, and composition are both types of part of kind of relationships, but the only difference is that aggregation is not as strict as composition. So in essence, what you are modeling when you're taking advantage of aggregation is a has a relationship. Okay, so this notion that you can I mean, you're still modeling some kind of part of relationship and ownership of sort, but it's somewhat weaker, right? um, it's a has a relationship, meaning that uh, the object on which the dependency exists, if it doesn't exist, the other object will be able to kind of like function normally, in other words, right? So it'll be like you would say something like a team has players, for instance, right? um, if you get rid of the team, the players will still be there, right? So aggregation, in simpler term here, enables you to model a has a relationship, and a house um, has rooms, is it, or something like that? or a house has, my house has a pressing iron, I guess, I don't know, my house has a refrigerator. If I get rid of the house, the refrigerator is still going to be there, right? Sorry about the room here. The room is not a good example here. My house has I don't know what my house has. Well, my house has bicycles. If I get rid of the house, the bicycles will still be there, right? So it's weaker kind of relationship here. And in other words, what you're saying is, so key things here is your modeling has a relationship uh, where the contained objects, the things that are contained within this larger entity, can exist independently without the container object. So it's a weaker type of relationship, if you will. Okay. Um, and it turns out that when um, when you're when you're modeling this using UML, it directed a solid line, right? But at the end of the solid line is a diamond symbol. Now what you begin to notice here is the well, the diamond symbol for aggregation is hollowed out, right? It's not solid. Um, this is what distinguishes aggregation from composition. If you look at composition, you'd have like uh, a solid diamond symbol. So you're using a diamond symbol that's not solid; it's hollowed out. Um, um, and then you have the line here, right? So in other words, what you'd be saying here is that um, a patient is a part of the patient record. A consultation is part of the patient record, right? If that makes sense here. Yeah. Anyways, I hope this is making sense here. There's some subtle differences here that would typically be confusing at first, right? One, it's a notation that is being used. For aggregation, it's a hollowed out, you're using a hollowed out diamond symbol, right? Where the diamond itself, like this shape here, is going to be on the container, like on the whole part, right? And the line is going to be on the class that is a part of the container object. So in this particular case, the patient is part of the patient record, and consultation is part of the patient record. Okay, and then we see that with composition, we are again modeling. It has a relationship. However, this is a much stricter version of a has a relationship, right? So the object is made up of the other object, and the composed objects cannot exist independently of the container object. And again, I'll have to apologize that I'm using more or less like the same types of classes just to showcase the variation in terms of the notation here. But a classic example here would be this would be human being. A human being has a heart, right? A human being has, I don't know what we have here, a brain. So the brain cannot exist, right, without the human being, is it? Or the heart cannot exist in isolation, right? It has got to be a part of this. So in essence, all we are saying here is that this is much stricter. And if you feel like this example I'm providing is a bit gory here, think of a vehicle, right? A vehicle will have, I don't know why I'm using it, but maybe a vehicle, I know this is, again, we'll be arguing here, but a vehicle has an engine, right? If you destroy the vehicle, the engine goes as well, right? It's going to be destroyed. It's like it's attached to the vehicle, if you will. Okay. Anyways, so these are like other types of relationships, right? Aggregation and association. And then it turns out that there are other forms of associations, like linkages, relationships that you can use. Like, for instance, you can specify a dependency, right? A dependency will specify a relationship in which a class depends on another class, It's like the example I gave yesterday, where we are trying to identify classes associated with a learning management system like the Moodle. Um, you have a course, you have a program. We know that a course is dependent on a program, right? There's a dependency relationship that exists there. If you think about it, right? Courses don't exist in isolation. They're attached to a program. When you tell somebody, I'm pursuing the Bachelor of ICTs with education, there's a certain level of expectation in terms of the courses that you're supposed to be enrolled into, right? In first year, second year, third year, and fourth year, you know? And then you also have so-called realization. This is in instances where you're trying to model a relationship in which a class implements an interface. I don't know if you remember your 2010 here. You were introduced not just classes, but they're so-called interfaces and abstract classes and all those things, right? Where they said that if you have a class, I mean an interface like public interface, public interface, uh, grade book or something, right? And then so you have an interface like this, and then you could have something like this, lowercase actually, not uppercase p, but the interface is class grades. You could say grades implements gradebook. This is what they taught you, right? I don't know if you remember this, interfaces and abstract classes and all those things. I don't know how much of this you remember here, but this should have been introduced to you by Mr. Mbewe here, and I think he may have mentioned that like your interface ideally would define some like methods, for instance, which would have to be implemented by the class, like in this particular case, grade. Right. So what your interface would do is it would define what the class would have to do, right? Not how it should do it. So in here, you'd say you'll have something like public static void show grades, right? Or something like that. So that in here, in the class grades, you'll have a complete implementation of the method show grades. So you typically would not have any implementation in the interface itself. And this is the reason why they say in Java, they say it's a contract, is it? Or in object-oriented programming, it provides the interface is a contract that defines a set of methods, ideally. But anyway, neither here nor there. So we're just saying that realization helps model this, right? So in this particular case, dependency, right? If you notice here, we're specifying that a thesis is part of a digital object, meaning that you have a dependence relationship. And this is how you represent dependency, right? It's a directed arrow with dashed line. Then you have the hollowed out arrow tip, right? Whereas with realization, so in this particular case, we are saying the class thesis is going to or the class doctoral student is going to implement thesis or something. So you have realization here, right? Dashed line, but you notice that the arrowhead here is not complete, is it? That's the difference between dependence and realization. Okay, and again, the question of in what instances do you use these things is contextual, right? In some instances, you would want to represent this sort of relationship such that they are much stricter, where you're saying if you delete, let's say you initialize or you reinitialize a patient record, then the patient details and consultation details are going to be affected as well, because you are for composition, because you're working with composition. Okay. Anyways, so ultimately, what you have is something that is akin to what you're seeing here. What you're seeing here, where Uh, yeah, don't know about that here. But so ultimately, what you're striving to do is to create a class diagram similar to this, right? Which comprises of a broad spectrum of relationships. And you notice that each of the different classes is almost complete here, is it? It's complete in that it has characteristics specified and also the methods or the operations. Granted, what you notice is that some of the relationships are not properly modeled. Ideally, we should have had relationship names here, right, on the linkages here. But we see that we have normal association here. Um, a user deposits a dished object. So multiple users can deposit multiple dished objects. And then we see that a bit stream, and I think it's a bit off here. It was supposed to be the opposite here, but we're saying a PDF document or a Word document or a digital object must always have a bit stream, but it can optionally have metadata, right? I swap these things out. In an ideal case, what we're trying to say here is when you have a digital object must have metadata, but it can have bit streams, like a PDF document or something. And then in this particular case, we are specifying that a library staff and students and an administrator can be generalized as users of the system, right? So we have a generalization relationship that exists here. Again, a student, there's a master's student and a doctoral student, right? These can be generalized as students. And the things that we discussed yesterday apply, right? Where we see that a master's student and a doctoral student, they're all going to inherit characteristic department and school, and also the function supervisor, which does make sense, right? Hopefully this is making sense here. Now, so graphical representation of classes associated with system implementation using OP approach here will require that you include other additional details. The other important details that you have to include other than the things that we've just discussed here, right? So just the tip of the iceberg here. And the reason why you may want to do this is tied to this notion of model-driven development. If you remember, we made mention of the fact that one of the reasons why you'd want your design artifacts to be complete is because in some instances you may want to take advantage of tools that will automatically generate code for you. So for instance, if let's say I wanted to automatically generate classes, these classes like Java code associated with these classes, what I would have to do is ensure that I'm representing these things in a correct manner, using the correct syntax, right? So syntactically, this thing has got to be correct. That's one thing. But also it has got to be comprehensive. And comprehensive means for each one of these different classes, I would have to specify the comprehensive set of characteristics or attributes and also functions or methods. Okay. Anyway, so what we're going to do here is just to showcase this thing here, showcase exactly how you specify, your attributes, not just the attribute names, but access modifiers and their explicit visibilities, for instance, right? The operations as well, access modifiers and the visibilities, right? And also explicitly indicate the associations between these different classes. And just to mention here that your class diagrams will abstract the implementation details in most instances, right? So, for instance, they will not showcase. The reason why we refer to them as being, static models is because they won't provide you with the details of the actual interactions that happen, right? So the behavior of the class would be omitted ideally from your class diagram. In other words, right? You'd say, well, my class has the it has the function supervisor or the function ingest, but you don't know what happens internally, is it? Right? The implementation specific details cannot be represented using a class diagram. It's just the static aspects of the system, in other words, right? Now, in terms of the actual specifics of like what exactly we need to specify for us to provide a comprehensive, complete, and syntactically correct representation of a class diagram, and this is best understood by looking at like a single class here. So we see here that, as earlier mentioned, your class diagram is represented as a rectangle with 3 segments. The very first segment will represent or be used for you to specify the class name, right? Your class attributes are represented or are specified in the middle segment, and then the operations are represented or specified in the third segment. So we have our class there, like this, and we see here that in instances where you're trying to model, let's say, an interface, for instance, instead of just having a normal class name, like in this particular case, the class name is digital object, what you do is you'd use these annotations, right? Use the glumps, is double greater than sign, double less than sign, right? And then you have the word interface in between, and you place that annotation on top of the name of the interface. So if digital object was an interface, what we're saying is we would have to represent it, the class diagram, as follows. Would say like this, interface, and then would have digital object, like that. Okay. If it's a normal class, you represent it as is, right? The name of the class itself. And then if it's an abstract class, you represent it in italics. So you change the formatting. I don't know if I have dia installed. I think I do. Can kind of showcase some of these things here so that hopefully this makes sense here, right? What you also notice here is that the names, a nice thing about the names is apply the similar rules that were introduced to you in 2010, right? Where it said, if you're creating a Java class, the name of the class must not have spaces. It's a single word, right? And typically you use camel casing, they said, right? Which is why here the D is uppercase and the O is uppercase, and you're combining them together, right? If you look at this dia, using dia, and I want to create, well, I'm just saying UML here, which is fine. If it's a class, what I would do is I'll drag and drop this thing here. You know, sometimes class like this. And then in here, I would say, I have no idea what's happening here, right? I'm gonna have to save this maybe. I don't know what's happening with my installation of dia. I'm just gonna try and see if I can delete some of these things. I mean, close some of these things, because I believe my my computer is misbehaving here, probably due to memory issues. I don't know. I could be wrong here, but yeah, you know, sometimes I dread. I don't know why this is. I don't know why this happens sometimes, right? Horrible things happen sometimes in life. Like, this is what's happening with me here. I don't know if I'll be able to. Yeah, I don't know what's happening here. I'll just kill win view or something as well. Yeah, it's this thing is not responding, which is stupid, really. I don't know what's happening here. I don't know if it's because of dia itself. I'm gonna kill dia as well. I don't know what's happening here. You know, it turns out it's because of that same application, right? Very stupid application. But I really wanted to use that as an example, right? I want to showcase to you exactly how this works. But I don't know what's happening here. If I can close this as well. Okay. Much better, hopefully. So what I'm going to do is I'm going to get die as well, and hope that this time around this will work without a hitch. Yeah, I'll have to reinstall this thing. I guess I wanted to showcase exactly how this works, but it appears it's not working. I'll fix this, and the next time we have class, I will demonstrate exactly how it works. I will demonstrate exactly how it works. Exactly how it works. Anyway, so what we see here is that we're saying that the class names are specified in the top segment, like this, where you have digital object. But when you're dealing with in an interface, you you add this annotation, the interface annotation. Yeah, interface. And then when you are dealing with an abstract class, you add it in italic, right? I don't know if you people remember the difference between an abstract class and a normal class and an interface. Do you remember what's the difference between? I mean, I've mentioned what an interface is, I guess, but what about an abstract class? What exactly is an abstract class? Okay, that's okay. Can you hear me, by the way? At least maybe people will be able to respond. If you can you hear me?
Yes,
Okay,
sir.
great. That's fine. We shall ask you in the exam the difference between abstract classes and interfaces. But so that's the top part, right? Remember, we're saying you have 3 compartments, right? And then for your abstracts, up to this point, we've just made mention of the fact that your middle component is used to specify the attributes, the characteristics of the class itself. Okay, but it turns out that these characteristics are ideally supposed to be specified in a certain specific manner, a certain specific way. You need to indicate the visibility, the variable name, the type, where applicable, even the default value. So it's like what you're doing implicitly is they're doing this, right? They've told you this. They've told you that you have public class. You have something like public class student. Typically, when you're creating a class like this, is you have class variables like private string student name, right? In some instances, you can provide values like private int student ID is equal to the default values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is what they've told you. And then you can also have private void set student name, right? And then in here you have string student name or something like that. And then in here you'd have something like this dot student name is equal to student name. Then you probably have something like public string get student name. So just access modifiers we discussed yesterday, right? When you're getting a name, you don't need to give it an argument, is it? It's say return this dot get this dot student name, right? Now here's the thing. If you look at what we are doing in the class diagram is we are trying to, at the design level, right? At design stage, we're trying to specify these things when you're creating a class diagram, these things that have been specifying here. And the idea behind this is before you can even start writing code, you need to have something like this. And this is what is going to give you an indication, an idea of how you should create this class. The how, right? And so what we are saying is, if you look at some of the things that they said we should be doing when we are creating, what did they say? When we're creating classes, is the private here specifies the visibility, is it? Visibility, right? So in other words, what we are saying is that when we're specifying attributes, we must specify the visibility, private, public, protected. If you remember, it's default as well, right? And then we specify the variable name. The variable name is this, student name, right? What else? The type of the variable, the data type. Data type is string, int, right? Variable name, student ID, right? Visibility, private, right? These are for variables. Default value as well, where applicable. In some instances, you provide default values. In this particular case, I've provided a default value, so that when I instantiate the student class, if I don't specify the student ID, by default, that student ID is going to be assigned this value. In fact, student name here, default could be John Doe or something, or Jane Doe, right? You understand? So what we're saying is that at a bare minimum, what you must specify are the visibility, the variable, the type, and the default value. And you notice here that the syntax is done in a certain way, is it? You start off with the visibility, and the visibility at design stage doesn't use the word protected, or public, is it? There's a certain syntax. If you notice here, I'm using a minus sign or a hyphen here, right? At the beginning here, there's a plus sign. I'll talk more about this here. But so what we see here is that similar to your operations, you have got to specify the visibility, right? The variable, that is the operation name, the method name, right? And then optionally, the specifications of the arguments, right, for the method, not the parameters. There's a difference. What's the difference between arguments and parameters? Oh, we don't know later on, right? So you specify in parentheses, you specify the range of arguments associated with that method. Now, when you're specifying the arguments, because these arguments, right, we specify them in such a way that they have a variable name and stuff. You have got to specify it bare minimum. You're specifying the variable name for the argument, or for the arguments. The type of argument, is it a string? Is it an int? Right? Is it a float? And then optionally default value. And then at the very end, you're specifying the type of the method. So there's something interesting here, right? For the methods, observe a method, right? A method would typically have a return type, right? Is it? Okay. Public, void. The public is the visibility of the method. Void is a return type. Void means you don't return anything, right? If you remember Java. String here means this method is going to return a string. And then what comes later is the name of the method. But when you're creating a method in Java, the syntax is such that you say, if you remember, public static void main, and then you have parentheses, right? The parentheses will specify, or are meant to help you specify the parameters, right? So that when you are running that method, if you say you evoke the method, you feed it feed it actual parameters, right? You have arguments, actual parameters. Well, you have parameters, and then you feed it actual arguments. Do you understand? So what we're doing here at design stage is it's like we're specifying these things, right? These things here. and we're specifying them in such a manner. Listen, let's use an example of, let's say we in our class, which is student, we have a method called public public okay, public int add numbers. When you're adding numbers, let's say two numbers, you're going to have to specify, you're going to have to specify what? The two numbers that you're going to, whose parameters you want to add, right? So in this particular case, I'll specify these are integer, it returns an int, but the two parameters will also be ints, right? Int first number, comma, int second number. Now, in here, we say return first number plus second number, like so. So what we are saying here is, before we write this method, we would have a situation where we are specifying that we are creating, in this particular case, right? We are creating, if there's this function, we are creating a method name is add numbers. But this add number, right? Visibility public. Return type int. Method name add numbers. Parameters. Parameters are specified because these parameters are like variables, right? The parameters will have the return type. The first one is int, is it? For the first one. Jesus. I'm going to say this. Parameter 1. And then I'll have parameter 2. The return type for parameter 1 is int. The name, the variable name is first number, right? And then for parameter 2, right? This is what you have. There's no default value, actually. You can have a default value. Default value is nothing. Default value not applicable, something like that. And then you have your parameter 2, right? Parameter 2 has a type, it's int. The variable name is second number. There's no default value, is it? Default value not applicable, something like that. Do you understand this? So the idea is what you're doing is you'd be specifying for each and every method in the class, you're providing these details. And true to that, when we want to represent this method, remember we're trying to represent this method called add numbers. For us to represent the method add numbers, we are saying, following the syntax, we first of all specify what? The visibility. It is public. It is public. I'll talk about visibility, which is a plus. And then you have the name, right? If you notice here, the name of the method, which is add numbers. And then you have your parentheses. In the parentheses, you have the parameters, is it? First number. The type is int, right? Comma, second number. The type is int, right? In fact, this should be, I think the type should be before something, or identify and then int. That's fine. This is fine. Second number is int. Now, what you notice is that in these instances, we don't have default values. If we had default values, what I would be doing for first number, I would say default value is equal to 0. Equal to 0. Second number default value is equal to 0. But there's no default value, so this is going to be the way it is here. And then at the end here, we specified the visibility of the method, the name of the method, and the parameters, like with their associated aspects or elements. And then towards the end, we have to specify the type, right? Full colon, the type, the return type here is int. So we have int. So in other words, in our class, what we're saying here is when we create our class diagram for but what is this? When we create our class diagram for student, we would have something like student, like this, and then student has student name and student ID. Student name, student ID. Just wait a minute, I'll specify the other things here because there's no type. Okay, student ID is int, like that. Student name is string, like that. You'd have something like this, right? And then in your methods, right? In the second compartment, because it's the first compartment where it's the name of the class, and in case you're wondering, but why Lighton? I'll do this. And then in the second part here, where we're specifying the functions, one of the functions is going to have to be what we've created, which is this. But of course, I mean, we know, you and I know that there's a couple of other methods, right, for this thing. It's not just this method here. If you notice, we have these access modifiers, the set and getter method. So we have this, which by the way is void. So we'd probably start with this, like this. It's public. It's public like this because we're setting values. We have student name of type string, like this. There's no default value here, which there's no default value here. What is the return? It's void. So we'll have void like this. And then here we have the getter method. In fact, I'll have the getter method right after this. We have the getter method, right, which is public get student name. But guess what? Nothing in here. Type, return type is string, like this. Do you understand this? So what we have, but why is this like this? What would be doing ideally, right, when you're working on this is before you actually start writing code, what you do is you create this during design stage, and then you use this as a basis to figure out exactly how you should create your class. And if you think about it, right, it's going to be quite intuitive for you to translate this into code. It's much easier than you second guessing, right? Oh, I'm going to create a student class, but what is it going to have, right? You know, we're specifying the how by looking at the static aspects of the system in this particular case. Do you guys understand this? Now, here's the thing, right? If you're thinking, well, but what about constructors, Lighton? If you remember your classes, well, constructors are represented as operations, so they'll be in here as well, right? So what that means is that if we are trying to have a constructor for a student, you'll have something like this, is it? Student. And then the overloaded version of your constructors here, the attributes here. If this is making sense. I know it is for me though. Do you guys understand what's going on here? Now here's the thing. In case you're sitting there and you're wondering, well, but how do I know whether to put a minus and a plus and stuff, right? There's a couple of things we've been discussing here. The visibility, it turns out, can be of various types. Ooh, I don't know what's happening here. My connection, I'm going to have to switch. I'm about to switch connections just now. Apologies. I'm I don't know if I'm going to be visible here. Can you still hear me? And can you see my screen? I've just switched connections. Okay.
Yes, we can.
Yeah. So what I was saying, right, is that in case you're wondering, oh, but what about the visibility, Lighton? What is that? It turns out, I don't know how much of this you remember, right? They told us that when we're creating classes, or when you're creating variables in Java, you can have something like protected int, then variable name, right? Or public int variable name, right? Um, so it turns out that the visibility can be of various types, like for instance, public, default, protected, private. So the syntax is such that if if the visibility is supposed to be public, you use a plus sign. If it's default, it's a tilde. If it's protected, it's a hash. If it's private, it's a minus or a hyphen. If it's derived, it's a forward slash. If it's static, it has got to be an underbar. And this must make sense, right? Because if you remember, your main method in Java, I'm going to leave you with this here. You must look at this, right? Your main method in Java, right, is such that I don't know what's happening here. Looks like this thing is your main method in Java is indicated as what? If we wanted to create a main method in the student class here, would have something like, if you remember this, public static void main, and then inside you have string args, right? This is what they told you. Now you can unpack this, is it? From what we've discussed, you can unpack this by saying, well, the main method which is visibility, public, but it's also static, right? Public static void main, the name is main, right? And then you have your parameters. A parameter is just one, right, which is args. If you remember, the args has what? It has the args has a type, right? It's an array, right? String, of type string, if you remember. This is what we do. Public static void main, this string args. This is a parameter, right? Name, the argument, right? So it's like the name and the type name, no default value. Name is args. Do you understand? And then more importantly, the return type is void. And so in fact, for you to specify the public static void main in a class, like student class, what we would have to do is we'd have to come here and say, because we've added it now, we have a new class. There's a class which is called main, right? And it's it's public main, you know, static. Jesus, static. And I can't even put an underbar here. I wanted to put an underbar. Static. Public static void main. In here we have the variable which is args full colon string, right? Array like this, and then at the end is void like so. Do you understand this? So in fact, there's a specific syntax that you have got to use for it to specify the visibility, right? I have no idea if you remember these things, but if I were you, I'd do a bit of digging to remind myself of the visibility, right? You remember the visibility? What did they say? What's the importance of the visibility? Sorry? What's the importance of the visibility? What are the implications of visibility of what we do here? Okay, I'll ask you. It's okay. I'll ask you myself. All right. So these are the visibility, right? So ultimately, like if you say putting things into perspective here, we see that relationships, right? For a class like this, you have relationships, right? Like generalization, right? Generalization relationship. Yeah, I don't know about that here. You have your aggregation and composition. In some instances, you have other relationships like realization and dependency, for instance, right? So you can model all of these different things, including the multiplicities that we indicate specific number of objects associated with that class that are linked to the other class. So we're saying many users can deposit many objects, for instance, like this, right? So ultimately, you're putting everything together so that you have something that is comprehensive like this, right? And you have all these different things: aggregation, generalization, composition, the multiplicities, and the like here. Now, here is the thing, right? The question now is, how do we put these different things together? Is like how then can I create this class diagram? Well, use a piece of software like Lucid Chart, right? And with Lucid Chart, for instance, you can create a blank diagram, if you will, and then just choose UML class diagram as your stencil. Or alternatively, you can use an existing template, right? So just search class diagram within Lucid Charts, and then you choose an appropriate template. Using that template, you can just edit out the class names, for instance. But what you want to do is you want to be very particular about the other syntax here, especially if you are looking at taking advantage of model-driven engineering. When we meet on Tuesday, I'll showcase to you, I'll do a demonstration of model-driven engineering using a tool itself, really. But ultimately, what I wanted to leave you with, and I've answered your question, the question I asked you, is they told us, right, that these access modifiers mean something in Java, for instance. And to a certain extent, this would be applicable to other languages, right? So what they're telling us here is that um, if something is private, it's only accessible within the class. So whether that thing is going to be extended by another class, it doesn't matter, right? A thing that is private is only accessible within that class. It's classic information hiding that was introduced to you. And then you use a default modifier in instances where those variables and those methods will be accessed in the package and in the class itself, right? Um, if something is protected, it's going to be accessible in the package, in the class, and all subclasses, irrespective of where they're in the package. And then if it's public, it's like you have global access, right? Do you understand this? Listen, I hope this has been enlightening, especially that you guys discussed this in 2010. Miss Goma says, I don't understand. What don't you understand, Miss Goma?
Oh, I didn't understand where you're coming with the plus and minus, but now I understand. It's fine.
Oh yeah, yes, great. All right, ladies and gentlemen, we have class tomorrow, right, Miss Violet Mtonga? I think we do. Do we?
No, I don't think we do. We only miss one class.
But why can't we have class? You don't want to have class with me? That's okay though. Um, yeah. So that was a joke. I'll see you guys on Tuesday. Thank you very much, and enjoy the rest of your Saturday. Bye.